Hey everyone, welcome to another session of a Global Hack Week. For today, I'll be getting us started with an introduction to ROS 2 specifically. And I wrote on the Discord message this will be a super beginner friendly stream, and we'll be focusing specifically on why open source projects are really cool and why most of the packages, frameworks, and things developed for robotics are open source. I know most of the things that we've covered so far are open source stuff, and ROS 2 is no difference on that. ROS 2 is also it's kind of open source, so we'll be getting started on that. Before I move further, please check into the stream in order to get your points for the weekend. By attending every stream, you basically get points. And also, if you build projects which are on the Global Hack Week list, you also get points for that. Hi, everyone. Good to see you. Plenty of people in here. That's great to see you. All right. So for today, we'll be doing plenty of things. So as I wrote on the message, we are going to be seeing an introduction to context about robotics and why ROS was created. And then we're going to see why Linux plays a key role in these specific things. And we're going to see architecture on ROS 2 and why is it different to ROS. We're going to see a simple talker and listener example. Then we're going to learn about some of the real applications of robots using ROS 2, because mostly all of the industry level robotics, they use ROS as their middleware. So we'll be learning why is it very important and why most companies and why industry uses this middleware so much. Awesome. So we have many hats from here from India. That's great to see. I heard Rust is difficult. I've never done anything in Rust, so I wouldn't know. This stream is about a ROS with ROS, Robotic Operating System. What do you think? I honestly have no opinion on Rust. I never coded on that language, so I wouldn't know. Hey everyone, nice to see you there. Hello, Jocelyn, love your streams. Came to your BCI ones last time. Oh, that's great to see. So for the last BCI stream that I gave, I felt really bad because I had my headset in there and I couldn't use it because the internet from my university was blocking the connection. It would have been really cool to show how it actually worked. I will definitely plan more BCI streams in the future, and also more robotic streams like this one. Are there any prerequisites? No, mostly for today, as we only have 2 hours. I'll be basically covering a lot of explanations and I'll be answering any questions that you might have. I would say I wouldn't consider myself an expert in ROS because there's so many things that you need to know, especially I guess the only way to master it is to use it really often on most of the projects. I've only used it in a couple projects, so I wouldn't say I'm super expert on the topic, but I definitely know how to get started and all of the basics and how to make it simpler for you to understand if you are especially new to all of this. Because when I was new to all of this stuff, honestly, I was a bit confused about everything. So hopefully today I'll be guiding you towards it and how to make it simpler for everyone as well. I've done simulation in ROS for autonomous food delivery robot. ROS is open source and easy to create robotics projects. Yes, I completely agree. And it's nice that you got into the simulation section. I'm just going to mention that during the stream, we're not actually going to run any simulation. But it's good to see that there's people with experience on the chat as well. So in case I also have questions, I can ask the chat for answers as well. Okay, so let me just load up the content that we are going to be seeing for the day. Yeah, it will be really cool that for next streams, maybe have a simulation ready that you can all run. But I definitely need more preparation for those streams. Usually I take about 3 to 4 hours to prepare the content. And then if it's more advanced content, like I need to build something or maybe a raw simulation, then I would definitely need more time to prepare those streams. So hopefully for today, we will only be covering some of the technical concepts, and then we're going to see some real life examples. And I'm going to show you some helpful links that you can use to get started with these with your ROS2 workspace. Okay, so brief introduction about myself. My name is Jocelyn. I'm a coach here at Major League Hacking. In there, you have my GitHub account in case that you want to see my projects and so on. I love Minecraft Bee plushies. I collect them. It's something really cool about myself. You can ask me about robotics, neurotech, or mechanical keyboards because I do collect them. I think it has been a while since I bought a new keyboard, mostly because most of my work has been done not like where I have my monitor and all of that stuff. So usually I work at my university, so I'm not going to be carrying my super heavy mechanical keyboard everywhere, which is really sad because I just recently bought it and I haven't been able to use it um, like too often. And yeah, robotics. I study robotics, so that's why I like to give streams about this. Some of the streams that I've been most proud of, it's the BCI ones and introduction to assembly, like making your first assembly code, because we got it a lot into computer architecture and how assembly works for low level code. So definitely make sure to check those out if you are interested in this whole robotics space. You can also ask me about the fellowship, like the MLH fellowship, or the GitHub Campus Experts program. So if you have any questions, feel free to drop them on the chat during the stream so I can answer them. And we can have a nice side chat going on. Because I always love to see your comments on the chat, learn about the projects that you're building, some of the cool stuff that you've done, so I can see how experienced you are, or if you're just getting started. If you have any questions about anything, feel free to drop them on the chat and we can definitely discuss them while the stream is going on. So I basically want to make these streams more dynamic. So not only me talking and like giving a bunch of stuff. So I also want to hear out from you. So anything that you would like to talk about today, feel free to drop it on the chat and I'll get to it when the time comes. Awesome. So this is the agenda for today. We have plenty of things going on. I will definitely try to do my best to explain everything in simple terms. I'm not going to go really into detail into some of the things because ROS is basically super broad and there's many things to know. Um, I would definitely need more time for me to explain everything in detail. And honestly, there's some things that I don't even understand yet. So I haven't reached that point where I feel that I mastered this technology. So, for example, if you ask me about LLMs, then I can tell you that I master that skill space. But if you tell me that if I master Linux and ROS, I will definitely say that I'm in an intermediate level where I'm still learning, but I can definitely explain basic stuff to get people started and to get people hyped up about these technologies. So for the agenda, we're going to have some context on robotics and what was done before the early 20s. And then we're also going to learn why Linux plays a key role in robotics and why it is a skill that you definitely want to have in your, well, basically your skill set, because Linux is used widely for robotics. Then we're going to learn the difference about ROS2 and why it replaced or is replacing ROS in the actual time that we are. I think it's going to be discontinued soon. But yeah, we're basically going to learn the difference on that. We're also going to learn about the ROS2 architecture or the ROS architecture in general and how it is structured to work properly for most robotics projects. We're going to see how to create the roster workspace and how it looks like. Then we're going to see a talker and listener example. So I'm basically going to go over the ROS to documentation and I'm going to explain some basic stuff. Because definitely installing ROS2 on your computer or your system, it definitely takes some time. to do and understand all of the things that you're doing, especially if you're new. So I'm going to try my best by going into the documentation and try to explain it in simple terms. Then we're going to learn about some ROS 2 tools and visualization. And we're going to see some example on real robots. So I'll basically just open up the code base that I use in my robotics team. So you can see an example of how an actual and bigger system takes over using these middleware. Awesome. So we are going to get started with the first section. So before ROS, which was basically on the early 2000s, robotics research and development, it was basically fragmented, not because there was not enough people interested, but because the software that they were using was sometimes it was not very united. So basically, every team, every lab, and every industry that wanted to build the robots and they have like different systems, they had to build custom software architectures, which will then run into incompatible code bases among industry. So before, like every lab, every team, every specific industry, they had that specific software, and it was not compatible between them. So it was very hard to adapt every component that they had on a robot, and there was zero modularity. So you basically had your whole system, and then if something failed, then basically it was over. It was also not standardized, and you could not reuse your code. So if there's no modularity, of course, you won't be able to reuse your code very easily. Because sometimes when you are building bigger systems, so bigger robots that have many things going on in the same space, you usually reuse your services, or you usually reuse your methods that you're using for a specific thing. It's the same thing as reusing your code for like an application that maybe you have helper methods that can be reused through your whole application. So definitely before that was not possible, and many developers, well, robotics developers and people that are into this space were basically a bit we're lacking modularity, and therefore it was harder to develop, and it took more time to develop these kind of interfaces. And then after that, I believe it was later up on the time the creation of ROS happened, which was a major breakthrough in this whole space. I believe it was developed by a specific lab in Stanford, though I'm not completely sure, but I believe it was developed there, and then someone else like took inspiration and then worked together to build what is ROS today. We have a question here. Hey Jocelyn, where can I get these slides after class so that I can read them by myself also? So I'll send them by the end of the stream. I'll make sure not to forget, and if I'm reaching the end of the stream and I'm not sending them, please remind me so I can send them over on the chat. Awesome. Okay, and when the creation of ROS happened, which by the way, ROS is Robot Operating System, it created an open source and modular and also standardized framework for building robot software so everyone can share and reuse the code. So I would say that is basically the core values of ROS, being able to have something that's open source, that it's modular, it's standardized among industry, and everyone can share and reuse the same code. So, development can basically happen faster in industry. So if you see a before and after era on ROS, before every robot basically spoke its own language, and it was a really target custom application for each robot. And now robots basically have a common language with a shared software ecosystem. So you can see these as basically before every company and every lab that wanted to do something related to robotics, they had to build the whole architecture from scratch every time, which basically took more time, and there was no standardization on this. And now you can basically get started super easily using ROS. And now if you see industry right now, you'll see that this is a skill used by almost everyone that's into robotics. So in my case, as I study robotics and digital systems, this is something that I see in my career. This is something that I use in my robotics team. This is something that I can talk to engineers from the other edge of the world, and they will basically know what I'm talking about because this is a standard in robotics industry. So if you are wanting to learn more about hardware and how embedded systems work, you definitely want to get into ROS because it's a key skill that you definitely want to have on your resume when applying to these companies. Okay, and then now that we covered a bit on why ROS was created and why was it basically needed by industry, we also need to talk about the role that Linux takes place in here. So Linux was it's basically known worldwide by now. It's another operating system that you can have in your computer. So basically, we have Windows, we have Mac OS, and then you can have Linux as well. Well, a distribution of Linux specifically. And ROS itself, it was built to run with Linux, specifically on Ubuntu. Ubuntu is a kind of, you can call it as a flavor of Linux. So it's a specific distribution of Linux, but everything is Linux in general. And sorry, and I will basically show you some of the most common Linux distributions out there, but specifically for ROS, Ubuntu was chosen to build ROS on top of that. So Ubuntu is one of the most developer-friendly Linux distros because you can basically install it and you can start using it super simply. So you basically have your browser, you can have your mail, you can have all of your apps in there. It's basically like having a Windows, but you have more control over your operating system, and the file management is also very different. The terminal is also Unix based, so it's very different from Windows. It's a bit similar to Mac OS, at least for the terminal. But yeah, it's another operating system that you can have in your computer. So if you definitely want to get into robotics and you want to learn more about this, definitely getting started with Linux is what you want to do on your checklist. So Linux should be on the number one space on your checklist because you do need to have some knowledge on Linux before getting started with ROS. That's why I mentioned that for today, it will be really hard for me to cover like all the important topics, but I will definitely guide you through on how to get started with all of these complex tools so you can then learn by yourself. And hopefully, on upcoming Global Hack Weeks, I'll try to make more streams about getting started with Linux or how to run Linux from a virtual machine or connect through SSH to a terminal that has Linux and so on. So I'll try to seek alternatives for me to teach how Linux works, but I'm pretty sure there's plenty of content out there online. So to understand the difference between them and why they need each other, so Linux is an operating system. It basically manages files, hardware, and networking between your computer and the actual system that you're handling. And then ROS, it's basically a middleware framework that runs on top of Linux to handle communications between your actual robot and the different software components that you're having. So you can not only run, I know that ROS, it's called Robotic Operating System, but it's not actually an operative system. So it's more of a middleware that framework that you install in your current operating system, and then you can run stuff in there. But the key to understanding why these two work well is because you actually need an operating system to interact with the files, to also manage the networking and connect your hardware to different ports. And then for ROS, you would actually need it to handle that communication between the code that you developed and then the actual components that you have connecting and interfacing through your computer. So that's why these two definitely go together. And I would definitely encourage you to learn about Linux and then distributions like Ubuntu before getting started with ROS as well. Oop, let me plug in my computer. Okay, and then moving on. These are some of the common Linux distros out there. So in our case, I mentioned that we use Ubuntu, which is the orange circle that's on the upper left corner. But there are definitely more distros out there, well, distributions that you can use in Linux that are targeted towards a specific stuff. So then we have the Arch Linux family, which I would say it's not very beginner friendly. Then we have also Fedora, and there's so much more distros that have been developed by the Linux community. I would say the most common one that you can find is Ubuntu, which is it's very friendly. You can get started. I mean, people that are not very uh, that are looking for something easy to get started, you definitely want to get started with Ubuntu in there. All right, and then moving on. Okay, so to get started with ROS, I've only mentioned ROS, but I never said that there's different versions of it. So far, between the creation of ROS and the actual time that we are right now, so 2025, ROS 2 is basically the newest version of ROS. So we only have ROS 1 and we have ROS 2. So as I mentioned before, there are some core philosophies that are shared by ROS worldwide. So it's definitely modular. You can reuse the code. It has language independence. You have your distributed computing, and most importantly, it's an open source middleware that you can use and you can also contribute to in case that you want to be part of the community. So now it's time to understand what are the key difference between them and why ROS 2 was developed to improve the challenges that were proposed by ROS 1 in its original state. So even though ROS, when it first launched, it was quite revolutionary, but it definitely had some technical limitations that made it hard to use, specifically for real-time systems or multi-time systems. So if we were talking about having something timed and having real-time operative systems, ROS was definitely lacking skills in there. So this was used worldwide by industry, but of course it's open source and it is definitely continued to be developed. So many people, basically gathered together and having feedback from the community, and that's when ROS 2 launched. So it was launched because it was not real time safe and it had weak multi robot support. And basically, if you had something in your architecture that failed, then everything started to fail, which is basically single point of failure. And then you could only use ROS if you had Linux. So you could not install ROS using Windows, or you couldn't install ROS in any other operative system. So it was Linux only. So of course, these definitely pose a challenge for people that were not very experienced into Linux or wanted to have ROS installed into their Mac OS or Windows OS as well. So the solution was just basically launch a new version of ROS that people can use, and that is what we're going to be focusing on today. So I believe that by now, ROS specifically, it's going to be discontinued. So the recommendation for people that have systems in ROS 1 right now is to change their whole system and convert their whole architectures into ROS 2. Why? Because it's basically going to be ending its support by the developers, and now ROS 2 will be basically the standard for robotics. So this actually was a discussion that we had with our robotics team like a year ago. We were facing some issues and we knew that all of our code base was in ROS. So we basically assigned different tasks for people to start converting the actual code that was using ROS 1 into ROS 2. So this is definitely something that people are doing right now if they have their architectures in ROS 1, because now ROS 2 will be basically the standard that will be used in robotics industry so far. And I'm not very sure. Let me actually look this up. I think ROS 3 is coming up soon, but I'm not very sure about that. Because I've heard some rumors on that. But I mean, I don't think it will make much sense as Yeah, I'm not really sure about that. I have to. I'll have definitely have to check. But yeah, REST2 it's what's basically being used right now so far. And now some of the characteristics that we have on ROS2, at least the most upper layer one, so the most easier to understand, is that it was designed to be scalable. It was also designed to be real time and cross platform, and all while keeping the previous ROS modularity spirit and core values that we basically shared before. Here are, I mean, basically, there are more specifics on why ROS2 is so important, but I'll definitely explain these details and maybe discuss them further on because it's like really specific things about how to run packages and so on that I definitely don't want to get into those details. So, and confusing you into getting started with this. Another important thing to keep in mind is that every Linux is an operative system, right? So Ubuntu, its distribution, it basically keeps updating every once in a while, like your regular Windows computer that sometimes starts updating. So Ubuntu as well, it also updates. So for each update that they're doing, ROS2 as well is updating. So there's different versions of ROS that you can have, and they have like new things coming up, and just like updating your phone and getting new features is the same with Rust 2, and it keeps updating every once in a while. So it's actually really cool because they make these super cool posters of all of the versions that they have, and they basically call them like they have an animal team going on. I believe the one that I use mostly is the humble one, mostly because it's is the best upgrade path for people that had stuff in Rust one. Then it's very easy to continue with this one, which is the humble house Beal. I think that's the name, but people just call it humble, which is basically the version that Linux the version that ROS manages. Right, and then moving on. So now we're basically going to get started with some of the core concepts of ROS 2 and how to basically understanding all of this stuff. So we are going to be getting through all of these definitions that are in here. I would say that if you are able to understand all of these concepts, then once you get started and once you start running this code, it will definitely be so much easier to get started now that you understand how the concepts basically work. Uh, oh, it's really sad because this was a GIF thing, but I guess that as I downloaded the PDF, it kind of took it as an image. All right, so basically, we have workspace, we also have package, nodes, topics, messages, services, parameters, actions, and finally, visualization tools. And then in here, we have a high-end diagram of how ROS actually works. So for example, we have different nodes, we have our service in here, we also have a topic in here, we have some messages going on around these lines. So you could say that this diagram basically summarizes everything in ROS 2, but we'll definitely go individually by each one of them. So the first thing that you want to understand is a workspace. So basically, having a workspace is just as your regular coding workspace. So it's basically where you are storing all of your files and all of your packages and all of your build files. So you can have several workspaces in ROS. So you can have different projects if you would like to call it that way. So for example, you can have a workspace on a drone, and then you can have a workspace on a rover, then you can have another workspace for a simple messaging app, and so on. So basically, a workspace is just a directory where you hold all of your packages and all of your build files in ROS. It's nothing, there's nothing hard to understand on this. It's just where you basically host your projects, and you can basically keep all of your projects in different spaces. And the second thing that we have is a package. So package, basically, it's the main organization unit in ROS2. Why? Because each package relates all nodes, messages, definitions on launch files. So ROS2, you can basically have different packages, which can basically be custom Python models that you have in there. So you can basically have packages for the motors of your drone. Then you can also have packages on things that are like that. And then moving on to the third concept in here, I would say this one is one of the most important ones because it's called nodes. So each node is a small focus program that performs one specific task. So this is one of the most important things to understand about why ROS is so cool and why we're talking about modularization. Because you in each node you can basically have a focus program that works for a specific task. It can be a sensor reading, it can be a motor control, it can be about navigation, it can be about basically something really specific and something really targeted towards an end goal. And then you can basically have multiple nodes in your package that you can use and you can connect them with each other. So this is a cool thing about having a modularized approach, that you can basically have different nodes going on with different focus programs lying inside them. You can see it as an example, having like separate apps on your phone, and each app does one thing well. So for example, in your phone you can have your timer app that does all of the clock stuff. Then you also have your weather app that checks the weather and tells you if it's going to rain and so on. So you can say that every app is an individual node and it has a very specific task. So you wouldn't want to use your weather app to know the time, right? So that's why every node that you have is very good and it's very specific towards an end goal. And this is what makes ROS basically be in a modular approach. Then moving on to topics. Topics are just basically channels where nodes, so the individual nodes that we have, they can subscribe and they can publish messages. So in here, for example, in this diagram, we have two nodes and they're basically communicating between a topic that's on the middle. So in your topic, you can either subscribe to a node or you can publish to a node. So if you see it as an example, you can have your group chat. So basically any node can talk. So any node can publish data and any node can also listen or basically subscribe to messages. So these two words are very used in the ROS industry. So you'll be hearing a lot about building publishers and building subscribers on your ROS tool or on your hardware or design architecture. Because you can have nodes that publish data, so basically nodes that maybe are publishing sensor readings, and then you can have another node that's subscribing to that data and it's doing something with the data that it's receiving. So let's say, for example, you have a node that reads color sensor values. So your publisher will be basically reading all of those color sensor values. It would be saying like, oh, I'm detecting red, I'm detecting orange, I'm detecting green. Then I detected red again, and so on. So it will basically be recording all of the data, and then through the topic, the other node will be able to subscribe to the data and maybe filter. So let's say I'm receiving all of the data, but I only want to move my motor when I detect red. So that's how you can play around with data, and you are able to unsubscribe or subscribe at any time that you wish to your other node in here that it's the publisher. So you can have nodes that are publishers, you can have nodes that are subscribers, and then you send your messages through a topic itself, which is basically the entity that communicates them both. Cool. And then talking about messages, which are the stuff that you're actually sending through. So messages are just basically data structures, just like they are, and they send information over topics. This information, it can be positions, you can have velocities, sensor readings, like the example that I gave earlier about detecting about detecting the different colors from a sensor reading. So messages are just basically being sent. It's a data structure that you send. It has a specific structure, and you can send the data in the format that you want or in the format that you would like to receive on your node. As an example, you can send linear and angular velocity commands on the group chat that we talked before. So it's nothing, there's nothing hard to understand on the message. It's something that you are sending through your topic. And then in here in this diagram, we can basically see an example. So we have our ROS2 node, and this node is a publisher. So what does this mean? This node will be basically it will be basically gather data from a sensor, from a motor, or from whatever end system that it is gathering data from, and then it is going to use a topic to send a message to other two nodes. So the topic, it's called slash example, and then your message type will be a string. So the message that you will be sending will be a data structure of type string. And then you can have two nodes that can basically subscribe to that message and read that message that you're having. So you can have multiple publishers, you can have multiple subscribers, and you can also have multiple messages depending on the data that you want to be sending. So for example, if we're talking about sending colors, then we might use a type of a string. But then if we want to use velocities or positions, then we might want to use a floating point data structure, or maybe an integer to send those positions. Or maybe you also want to, you can use an array as well to send your data. So it depends on what you want to be sending over those messages. But yeah, just to be clear, messages is just basically in a specific data structure that you send it over topics, and your node subscribers basically receive that data that you have in there. Mm. And then we have services. So I would say services are a bit harder to understand. But so far we've seen, let me go back. We've seen workspace, packages, nodes, and now topics, messages, and now we're gonna see what services are all about. Because in here from this diagram, we basically covered topics. We also covered nodes. We covered subscribers and publishers. But now it's time to cover the services section. So let me move on to that section. Here we go. So services are just basically like making a synchronous request response pattern between nodes. So if you are familiar with synchronous programming, you know that you need to send a request in order to receive a response. So it's just like your regular normal coding programming. So you call a function, your node asks, for example, what is the battery level? And then your node waits for an answer in order to send that answer back to the other node. So as an example, you can have a battery monitor node that provides battery percentage when a control node requests it. So this is an example. We have our service in here. Then we have our service node. We basically make a request, and then once the request is approved, then we get that response sent out to our other node that we have in there. I believe I have a link to show you to understand services better. So let me just open that up. Let me share my screen now. There we go. So there's actually a difference between topics and services, and we also have actions. Well, we're not going to go into the actions part of it. We're just going to see the difference between topics and services, because there's actually a difference. So in here in this article, it basically covers the three main ways nodes that can communicate with each other. So we have topics, we have services, and we also have actions. Again, we're just going to be covering topics and services. So just as it says, use topics for continuous data stream. So, for example, if you are generating later data or data that needs to be published continuously, as long as the robot is up and running, so maybe information about your environment, information that you use for navigation, then that information you want to use a topic for that because it will be basically start sending, well, basically publishing messages just when it gets started. And now all of your nodes will be having that data in there. And then it says that the data types used in topic-based communications are known as messages. So nodes publish messages via topics and nodes subscribe to messages via topics. So you can subscribe and publish to a topic and you are sending a message, which we basically said that we're going to be sending that specific type of message. And then for services, you want to use services for quick request response communication. So basically, a service, what it's going to do is that it's going to send a request, typically for some data, to a node. And then that node will basically reply with the request and with a response. Yep, this is just a diagram that I was showing you earlier on, where you have your node and then you basically want to have your request message. So the request passes through the service, then it goes to the service server, travels back with the response, finally reaching your end client over there. Have you all done the Turtlebot thing yet? That's actually a really fair question. We are not going to be doing that today, but we are definitely going to get started on how to set up to use the Turtlebot simple demo. But it's definitely a super beginner friendly tutorial if you want to get started with ROS 2. Can I really do something with ROS while not having the hardware robot kits? Yeah, you definitely can. As long as you have your computer, you can definitely get started into familiarizing yourself with all of this. Because you can basically simulate your own robot with ROS. The only difference is that you won't be getting real data. So you can basically fake your own data, like your own messages, for example. So you can basically fake your own motor position data or the color sensor data that you're getting. So as long as you have data being fed into your system architecture, you can definitely get started with ROS in there. And this was the question. Can you send that link? Yeah, I definitely can send this one. This one, I would say it's a really straightforward on the difference between topics and services, which I guess it's one of the most common questions that people have. And this is also organizing files and folders inside a ROS2 package. Yeah, but we're going to see this one in a second. Okay, so now we basically understand the difference between a topic and a service. Then it's time to move on to the parameters section. So parameters are are a small section of what ROS2 is. So these are just basically having configuration values that nodes can access or update at a runtime. So it's like having some threshold values for detection, or maybe if you want to have an initial position, or a preset value set up, then you want to use parameters. And also, if you want to update your parameters during runtime, that is also completely possible. So for parameters, here are some examples. So you can basically have different parameters like strings, integers, floats, and then the string can say hello, it can say 5, it can say 12. And you can use those parameters for the same section of the robot. So let's say I want to use these parameters on my arm, but then I also want to use those parameters on my camera. So you can definitely do that, and that's why they can be configured so that nodes can actually access or update those parameters during runtime. Awesome. So far, we basically saw all of the explanation on what ROS2 is and some of the easy steps to get started. So now for the second section of the stream, we're going to see plenty of examples, and we're going to go into the documentation and some important articles so you can see some real life examples of how this actually works. So if you want to get started with ROS 2, I would definitely recommend you, number one, to start mastering Linux basics, then install ROS 2 in your computer, and then try the Turtle Sim simulation as some hacker was mentioning before, and then explore some online resources. And I would say, as a fifth step, try to make a small project by yourself so you can definitely get started with that as well. So for now, I'm going to send on the chat. Um, I'm going to send the official documentation guide to set up ROS 2. So before I go into there, I already sent that on the chat so you can see it as well. Then we have a question: what kind of projects can we make for a beginner? So I would definitely get started with the Turtle Sim simulation, and then I would also try to make a simple publisher and subscriber notes in there. And then after you master those two, I would say that you will definitely have ideas for new projects. So it can be like reading data from a sensor and then using that sensor data to send something on your other node and stuff like that. But if you definitely get started with the turtle sim simulation, I am completely sure that you will have a really nice idea of how to use ROS2 for your further projects. Awesome. So I shared the documentation link over here. Please go ahead and start reading how it works. I'm going to give a 5 minute break for you to go over that, and then we're going to go into seeing how the turtle sim simulation actually works, and then I'm going to try to find a nice video to see how it is up and running. Okay, I'll be back in 5 minutes exactly. Please make sure to check that link that I sent over on the chat and check into the stream in case that you haven't already. Okay, so hopefully that was a nice break for you to go over the documentation really quick. And I was also able to find some helpful links for you all. Specifically, find I wanted to find an important video to show you about the actual robot that I'm building. So let's continue. Where was I? Let me actually load a different screen in here. Okay, it's actually loading. Remove from studio. Okay, so let me move on to the slide where we were. We actually covered so much so far. Okay, here we go. So setup and workspace management. So this is the first step in order to get started with your ROS2 project. So the first thing that you want to do is have your folder created. So create a directory called ROS2 workspace or any name that you would like to have to identify your specific workspace, and then have a source folder inside it. So basically, after creating that, then you want to use Qualcomm build to compile all of the packages that you just created and basically tell your workspace that it's going to be a ROS2 project. So these are the commands for you to do it. So mkdir is basically to create the folders, and then you sourcing into the ROS2 workspace, and then inside there you run Qualcomm build. And then after that, you have to do source install setup.bash in order to know that that is a project that you're referring to. So I know all of these commands might sound like a lot. That's why I'm telling you that you need to have at least some basic understanding of Linux commands before getting started with ROS, because it can definitely be so much more overwhelming by seeing all of these commands. Okay, so before seeing some of the example commands that you can run, I'm gonna go directly into the roster documentation so you can also see that as well. So let me just share my screen with that one. Share screen. There we go. So for this one is the one that I basically shared with you. I'm going to make this bigger so you can also see it better. So in here, we're basically going into installation, into installing Humble, which is the one that I would say it's at least the one that I used, and it's also one of the best supported ones in industry. And if you see in here, you can click edit on GitHub as well, which means that this is all basically open source and running. So in here, it says we support building ROS2 from source on the following building platforms, and we have Ubuntu Linux, then Windows 10, and Mac OS. I actually had a hacker in here ask if you need Linux OS for this, or can we install ROS on Windows also. I would strongly recommend for you um, to run it on Linux, as it is the standard, and it will be so much easier for you. In Windows, it's actually much more harder. Worst case, if you don't want to use Linux, then you can run ROS in a Docker container. If you're familiarized with Docker containers, then you can definitely run ROS2 from a Docker container in there. So after in here, it also tells you about contributing to ROS2 core packages. So you can definitely see, you can definitely visit this about the latest development source, and then you can also see where can actually developers work on these projects. Um, like for example, distributions in here, and you can see all of the distributions. And here basically tells you what a ROS distribution is, which is a version set of ROS packages, which are akin to Linux distributions. Example, Ubuntu. And then here are some of the recent lists in here. So this is the one that we are using, the Humble one. But the newest one is this one. It's called Kilted Kaiju or something like that. But there are older um, distributions in here. Yep, and you can see all of the different distributions that are out there. Right now, we are using this one, Humble. And then if we go back to the installation and we select Ubuntu Linux deb packages, then you can also see how to get started with this. So some resources, and then setting up your locale. So make sure you have a locale that supports UFT8, and then you basically run all of these commands. Then you need to set up sources. So again, run all of these two commands. Then you do apt update, which is just basically to update all of the current packages that you have. And then you actually get to install the ROS2 package, which will have all of the ROS2 repositories configured in your system. And you can basically do that by running these commands in here. Then you do sudo apt update, sudo apt upgrade to make sure that everything's correctly and running. And then in here, this is just some external things that you can install. So you can have, for example, ROS Humble Desktop, and you also have the ROS base or the dev tools as well. It depends on which one you want to install. And then finally, you do a source to all of the setup bash that you basically did. And that will be all. So that's all for getting started. So I know I mentioned that it is going to be challenging to install because there are some cases where after running these commands, you get some errors. But don't be scared. Those errors can usually be fixed super quickly. You just copy paste them into your browser, and I'm pretty sure someone will have encountered that issue first, and you can basically find a solution for that. In my personal opinion, if you get issues when installing this, I would not recommend you to tell ChatGPT about the issues. I would definitely encourage you to search the issue first online, see if someone else encountered the same issue, and then if you can't find anything, then you can proceed to paste it on ChatGPT. But yeah, for these cases where you are installing something big and yeah, basically something big, I wouldn't recommend using GPT. So first, try searching for help online. Try to see if someone else encountered that same issue, and then you can move on. If you don't find any answers on any forum online, then you can move on to GPT. I did run it on my Mac OS my first time. If anyone's wondering, this will be my first time running on Linux. Oh, that's interesting. I've never run ROS on Windows or Mac OS, so I've only heard from friends and from people that it's harder um, on systems that are not Linux, and it actually makes a lot of sense because ROS originally was built to work on Linux, so maybe the second version of ROS has not it's not very compatible and it's not very common to use it on Windows or Mac OS systems. But I do agree that maybe it works better on Mac OS than Windows because their systems are the same. So since I've got a Mac, do you recommend a Linux virtual machine for this installation? Thanks. So if you are going to be continuing using ROS like very often, I would definitely recommend you. Yes, you can use a virtual machine. So in case that you screw things up, then you can just delete that instance of the virtual machine and get started again. So actually, for the first times that I started using Linux and ROS, I installed a virtual machine on my computer, so I could definitely test that. And then I run the basic examples for Turtle Sim and the publisher and subscriber examples. And then once I got familiarized with Linux and ROS, then I did the partition of my system. So I basically now on this computer have a double boot. So I have Ubuntu, and then I also have Windows on the other disk as well. 100% harder, there's less accommodation. Yeah, I definitely agree with you on that. And it also makes sense because most people that use ROS, they use it with Linux. So I would definitely agree with you on that. So I imagine it can be much more challenging to do that. Okay, and yeah, so basically these are all the commands that you need to run. If you have your Linux set up correctly and everything's working properly, you shouldn't have any issues. And then once you run this last command, then you can start trying some examples in here. So I definitely recommend you for you to go into this guide, and I think I already sent this one, but I will send it again just in case. So definitely go ahead and try these examples. So, oh, this is actually a bit different. No discovery and communication. Yeah, this is just basically a router. I wouldn't say we necessarily need that, but it's definitely helpful for people that are a bit more visual and want to see things in a more visual way. But yeah, after running these examples, and if they run correctly, then you are basically set up and your ROS2 has been successfully installed on your computer. And then you can see some next steps, which are tutorials and demos. And I definitely encourage you to go and try to do as many tutorials as you can, because they are super intuitive. So these ones are the beginner CL command line interface tools. So how to configure your environment, then using TurtleSim, ROS2, and RQT for graphs. And then it will definitely show you like all the commands that you need to run, and then how to start your turtle sim simulator in here, which is just a turtle that starts moving, trying to simulate like if this was your robot, and so on. And yeah, and then you can have this RQT thing in order to see all of your nodes in case that you want to visualize them. And then let's see if there's an image in here that shows it. There isn't. But yeah, this one should definitely get you started. These are the beginner tools that you can use, and then you can move on to the client, some of the most common client libraries, like using Colcon build in order to build your packages. So in here, it says that Colcon is an iteration on the ROS build tools like Catkin Make and all of the other tools that were used before on ROS number 1. And then now for ROS 2, we use Colcon, which is basically to build all of your to build your ROS2 project. Basically, it will guide you through the basics of creating also a workspace, then creating creating a package, working a simple publisher and subscriber in C++ or Python, depending on what you want. But yeah, I would say the documentation for ROS2, it's really good. If you want to get started, first do the installation steps and then do the easy publisher and subscriber example. And then you can move on to the more complex examples, which are in here over tutorials. Start with the beginner CLA control command line interface tools, then move on to client libraries. And then if you are feeling like wanting to explore more, then definitely check these ones out as well. But yeah, I would say that will be all for the ROS2 documentation. If there's any questions or any comments, feel free to drop them on the chat. I already shared this link with you in there. As this is only a 2-hour stream, I won't be making any real life example by myself, but definitely expect more tutorials like this one coming up in the future, where we will actually be building our own project. And then if you get started now, then it will be much easier once we reach those other streams that we might be having at upcoming Global Hack Weeks. We've got questions over here. My laptop is not in very good condition as it is a cheap one, so I can still use ROS2 on my laptop. Yeah, I would say you definitely can. I mean, the only difference is that if you want to run like super big systems, then it might be slower. But just for getting started and running these simple examples, I would say you won't have any issues with that. And also, it depends how you are installing Linux or how you will be running Linux. Because if you have, for example, a Windows computer and then you are running Linux on a virtual machine, then it might be a bit slower for you, as running a virtual machine inside your computer actually requires some processing. So maybe your virtual machine will be a bit slow, but there's nothing bad on that. I mean, you will still be able to run it. And then if you have your computer and then you do the dual boot, so basically have Linux and Windows both at the same time, then depending on how much space you have on your computer, so let's say that you have what's an average, so 250 gigabytes. So I would at least allocate 150 gigabytes for Linux only, in case that's only in case that you want to divide your disk in order to have both operating systems running at the same time. But for getting started and getting used to Linux, I strongly recommend the installation of a virtual machine first. All right, so what was I going to show you next? So these are the tutorials. I'm also going to share the link for this one. There we go. Awesome. So these are the tutorials that you can all see to get started on ROS 2. And as for the virtual machines that you can use, I definitely recommend VBox. I think it's VirtualBox, this one. I would definitely recommend this one. Wait, no. Let me just double check. No, virtual machine. Let's see. I use this one. VirtualBox. This is the one that I've used, and then I just basically downloaded that one. And then once you download the virtual machine, then you can follow. Let me see if I can find the official one. I believe this one is another one, and you can actually install like the ones that already have packages on it, so you can install. I definitely recommend Linux 22. Oh, I'm actually downloading this. Oh, I don't want to download that. Yeah, so download VirtualBox for Linux hosts. Or another thing that you can do is just download the VirtualBox thing, and then you can download, if you go to like download, I think Ubuntu download, you can download Ubuntu directly and then just load that disk on your on your virtual machine. For doing all this process, I strongly recommend searching a YouTube videos that you can follow along in order to set up your virtual machine. But you will definitely need to download Ubuntu from here, and then you will need to download your virtual machine app, where you will be basically running your Ubuntu disk. And it will be very easy to access because you would only basically have your app where you click on it and you start booting your virtual machine, and then you will basically have Linux on your current computer without actually having to divide your disk and all of that long process that you have to do. Of course, by running a virtual machine, it will be much slower. So you can anticipate your virtual machine to be slower compared to your regular Windows system that you have on your local computer. So I guess that's it's not a strong point for virtual machines, but I definitely recommend that for beginners. So in case that you screw things up and you made a mess on your Linux system, then you can just delete it and create a new one, and there will be basically no damage on your computer in there. All right, so after learning about that, then I guess I'm gonna go and show you some of the common examples that we do at our robotics team, which is this one. So firstly, I'm going to show you the documentation page of my robotics team. Wait, this one's not the correct one. Yeah, this one's just basically the API docs. But this one is the pretty one. So if we go to ARIAs, there we go. So we have different areas in our robotics team. And to give a bit of context, we participate on a competition called At Home, which is basically the development of an autonomous home assistant robot that can basically it can basically bring you drinks. It can identify different guests on the house. It can navigate to different sections. It can pour coffee and things like that. So it's kind of like your own home assistant that you can basically that can basically navigate autonomously. So as having a big robot, of course, we need to talk about having different areas, which are basically having different models in order to have a bigger system. So we have the navigation section, we also have manipulation, integration, human robot interaction, electronics, computer vision, and mechanics as well. So these are all of the areas. I specifically focus on human robot interaction and computer vision section of the robot. And then if we go back in here into the most updated docs, for example, if we go to human robot interaction, then you can see all of the different things that are in there. So for example, we have a RAG service that we have in ROS running, and then we can see all of the architecture and implementation. Like we have a RAG service node that implements the service that listens for question requests and responds with generated answers. So in here, we basically have this node that is constantly listening for questions. And then we can see, no, let me see if I can find another one. Maybe computer vision. Yeah, like in this one we have another example. Like this is one model that we're using, and then we can see the configuration of the ROS node. So the ROS node is basically called Moondream node, and then you can subscribe to different topics. Like in this case, we're subscribing to the camera topic that receives a message of type image. So we can have all of the frames from my image being read. And then we have different services. So we have the beverage location service, which basically locates a beverage. We have person posture in order to detect the posture of a person on that specific frame. Then we also have the query service that runs an LLM in here on the image. And then we also have the crop query that describes a crop region based on the bounding box that it has. And then we can also have different methods on our ROS node to do specific things. And yeah, this is basically how it works. And this is just kind of the project structure that we have. So we have our client, you have the different files in here, and then the scripts where the node is actually hosted. So right now I can actually go ahead and show you some real life nodes and how it will basically look like. So this is our GitHub repository. You can basically go ahead and visit it. I'm going to go ahead and share these on the chat in case that you want to see it as well. I want to show you an example of how the robot actually looks like. Here it is. This is basically like the robot that we have, which is an X arm. And if you can see in here, it has a gripper in here, and then it also has a camera, which is a set camera that is kind of the eyes of the robot for all of the computer vision stuff. I believe this one is only for the LLM execution demonstration. But let me see if there's something. Oh, yeah. Let me see if there's an example where it actually moves. Because this one was only for the demonstration of the LLM models that we use for the GPSR, which is a specific task for the competition. Let me see the second video. Um, Wait, I think it was. Oh, this one is from the actual competition. Let me see. So basically, how this works in the competition, there's different tasks that you can do. This specific task is called GPSR, which is general purpose service task that you can do. So in this example, well, this is a video of the actual competition. We have the robot in here, and we have these guests in the house, and the guest can basically ask for a command, and the robot has to act and do that command. So the command that the person actually said in here was, let me see. It was look for a person raising the right arm in the bedroom and follow them to the living room. So of course in here there's many things that you need to coordinate at the same time. So you need to identify the person that's raising the left arm in the room, which basically has to do a lot with computer vision and also on how you move the robot in order to find that person that you want. And then it also says follow that person to the living room. So in that case, the robot needs to be able to navigate autonomously from the kitchen to the living room or to wherever the person is actually moving and following them. So of course, this is only possible using ROS2 nodes. Otherwise, it wouldn't be possible because there's many things that are going on. There's many messages that are being sent. So you definitely need to have everything under control. So let's actually see how it works. So in there, the robot just basically double confirmed the command that the user made, and then it's making the robot is doing its chain of thought thing. So it's basically saying, let me see, saying I am planning how to perform your command. Please wait a moment. I will now execute your command. And now it says I will go to the bedroom to find the person that is raising the left arm. So it is now going navigating autonomously to the bedroom, which is on the other section. And then we have our person in here, well, that it's a volunteer that will be raising the arm, hopefully. So now the robot is changing the camera and searching for the right arm. So it's moving, and there we have our person that's raising the left arm. I found a person raising their left arm, and then it says, please approach me. So the person goes near the robot, and then the robot will basically follow the person in order to go to the living room. So this might be seen as, oh, it's very simple to identify a person raising its hand and then just moving along, but there's many things that you need to take into consideration in order to make this possible. So you need to be aware of every section in the house that you have. It also needs to be aware of not collisioning or crashing into the actual objects that are there, because if the robot accidentally crashes with like the table or the chair that's in there, then our running time for the competition will basically stop, because you are not allowed to crash into things, even if it's a super small bump or just basically like touching the stuff. Then you will automatically be your round will basically end in there. And yep, those are some of the examples. If you go in here, for example, on the vision section, which was mostly where I was working on, and you can see all of the packages in here. If you go in package, then you can see each individual ROS package. I worked on the Moondream run in here, and then you can see the launch node in here. You can also search for the different scripts, and we can visit the Moondream node, which says node for Moondream functions. And then in here, we can see all of the topics that we can subscribe for example, camera topic, person poster topic, crop query topic, and so on. So all of the topics that we have that we can basically subscribe in our node. And then it's super simple. So you just basically initialize your node and you can subscribe. So create a subscription to that specific topic, or also create a new service for a specific topic that you have in there by just doing self.create service or self.create subscription. And then after doing that, then you can basically just start creating your Python methods just as normally as you would do in a regular code. So for example, the crop query callback, or you can also have the beverage location callback, which are just Python methods that you can use in order to produce a response. And then to see the messages, let me see if I can find them. I believe they're in here, Frida constants. Let me see. Nope. Oh, well, these are just basically some of the constants that we use for the different sections that are, for example, in the living room, in the office, and then you have mapped out different navigation stuff that the robot can basically navigate to. But let me see if I can find, oh, here they are. So these are some of the messages that you can use and some of the examples. So for example, in here we have a variable type bool that's called follow phase, and then its response is basically bool success. So that's how you can basically run in there. And you can see the vision as well, the messages in here. So for example, these are some examples of messages. For example, the person message, it has the name of the person, and it also has the coordinates of where the person was found. Um, you can also have, for example, beverage location. It has the request, the beverage, and then it returns the location and a flag of success whether it detected the stuff correctly in there. And yep, I definitely shared this with you already in case that you want to check it out. But yeah, I guess let me stop sharing this one. Awesome. So for wrapping up, I guess we covered all of the ROS stuff in there that we wanted to have covered and how to run a simple example. We also saw some of the steps that you can follow in order to getting started with ROS 2. So basically mastering Linux basics, installing ROS 2, try the total sense simulation, and then also explore online resources and do the simple publisher subscriber node that you can use as well. I'm going to go ahead and send another link on the chat for you to provide feedback on the Global Hack Week streams. Very important for you to fill this out. It's just a 2 to 3 minute quick survey in there for you to check it out. And I'm also going to go ahead and send you the slides presentation in case that you want to see it as well. On the slides, I also included some, on the last slides, I also included some common commands that are used in ROS 2. They were basically done with ChatGPT. You can notice by the style of the chart, but it's definitely some of the most common commands that you're going to be seeing, and that at some point you basically have to learn them because it's the only way for you to start running all of the stuff that you have in there. All right, so that will be all from me. I'll stop sharing my screen now. And it was very lovely to see you all. I won't be making any more streams on these open source week, but I definitely encourage you to visit all of the other streams that will be going. So for today, we will be having later on a Scribble.io mini event, and then we're going to continue with the GitHub profile creation. I think this one is with Carrie. Which is really cool. And then let me see if there's something. Oh, I would say this one will be interesting. Vector Search 101 sounds interesting. There's many things going on for open source in here. Also, LangChain will be interesting for people that are into LLMs and stuff. So yeah, we're just in day 3, so definitely feel free to explore the schedule for the rest of the days. And if you have any questions or comments, feel free to drop them now, or you can also contact me directly on the Discord. You can ping me in there so I can answer your questions. And yeah, definitely keep tuning in. I will definitely make more streams related to robotics and neurotech in the upcoming Global Hack Weeks. If you have any requests for a specific stream or something that you want to learn about, make sure to let me know on the Discord so I can also take that into consideration, or also make sure to let me know so I can basically do streams that hackers are excited about. So exciting. Thank you so much, Jocelyn. We'll leave you feedback. Awesome. Great to hear. Then, yeah, I guess I'll be logging off for the day. Make sure to continue participating on the rest of the Global Hack Week streams. And I will see you hopefully on the next Global Hack Week that will be happening next month, that we are also closer to Christmas. So that's also exciting. And yeah, I will see you later and continue having much more fun. Bye, everyone.